Welcome to episode 2 of my Raspberry Pi experience, a beginner's guide, yet documenting my getting started journey with the Raspberry Pi crate-sized computer board designed for learning electronics and computer science. On the previous episode, we looked at how to set up the Pi, connecting the HDMI display to the Pi's HDMI port, choosing a suitable power supply for powering the Pi, connecting speakers to the 3.5mm audio jack. We also looked at downloading and installing the operating system Raspbian and ended off with a booted Raspbian GUI. Right now, if you have been following closely, you should be seeing the Raspbian graphic user interface and are just gearing up to explore the Pi. And that's exactly what this episode is all about, exploring. But first, let me share a story on how I got a hold of my first Raspberry Pi. The year is 2016. I'm preparing to start my final year undergrad project in electrical engineering at the Nelson Mandela University, previously known at the time as Nelson Mandela Metropolitan University. As my undergrad project, I decided to join the NMMU Formula Student Racing Team and learn how to build Formula Student electric vehicles. I didn't know much at the time about EVs, but was particularly interested to learn more about energy storage and management. Thus, I was given a project on the control system and battery management system departments. The task was simple. All I had to do was to read off CAN bus messages from the battery management system, such as state of charge, state of health, and many more other battery-related parameters, and display them on a small LCD on the driver's cockpit, so the driver is fully aware of the battery's operational parameters. Long story short, a previous student had left behind a credit-sized computer board that he had used on his project. I had to build a user interface for the driver at a limited budget and thought this small computer would do the trick. Together with CAN bus interfacing circuits, the Raspberry Pi was useful at reading the CAN bus messages and using languages such as Python to create a user interface for displaying useful information on an inexpensive HDMI 4-inch display on the cockpit. I fell in love with the board ever since and went on to build other cool projects. So this series is just merely a journal into my getting started experience with the Raspberry Pi. In this episode, I hope to show you exactly how I've managed to fit the Raspberry Pi as a computing device of choice I use on my daily activities, similar to my laptop and smartphone. In the previous video, I talked a lot about things that are recommended for use with the Raspberry Pi, such as using a suitable power supply, preferably the Raspberry Pi power supply, and connecting to an HDMI monitor so you can use your Pi like a normal desktop PC. This is my journal and I'm supposed to be sharing information on how I prefer using the Pi, and to be fair and honest, I don't use neither an HDMI monitor nor an inverter power supply on my Raspberry Pi setup. I do use a display and power supply, but rather in a more portable form, feeded onto my laptop. For this setup, all I need is a single power USB cable to power my Raspberry Pi, and using a tool called VNC, I can remotely access my Raspberry Pi using the user interface via a common network connection that I usually establish using my smartphone's hotspot Wi-Fi connectivity. So my network is made out of my Raspberry Pi, laptop, and smartphone. Now let me show you how you can get this setup working. I'm currently using a Pi 3B Plus. This model comes before the new Raspberry Pi 4, and one visible difference is the different power ports. The Raspberry Pi 3B Plus model uses a micro USB port, and the Raspberry Pi 4B Plus model uses a USB-C port. The difference here is power related, as the Type-C port is only used for powering the Raspberry Pi and can be connected to high wattage power supplies of up to 100 watts. In this series, I'll be making use of the Raspberry Pi 3, The Raspberry Pi 3 is powered by a 5 volts micro USB supply. Exactly how much current the Raspberry Pi requires is dependent on what you connect to it. It is, however, recommended to purchase a 2.5 amp power supply from a reputable retailer for sufficient power to run your Raspberry Pi. I, however, use my laptop's USB ports to power my Raspberry Pi, typically on USB 2.0. You can get a max current output of 500 milliamps at 5 volts and 900 milliamps at 5 volts for USB 3.0, the blue USB port. The Model B uses between 700 and 1000 milliamps depending on what peripherals are connected. On my daily setup, I run the Raspberry Pi over a VNC connection, thus this frees up my peripherals and I don't need much power to run as a result. I only have my Raspberry Pi camera connected on the camera port, and that requires about 250 milliamps whenever I'm taking pictures, and this can be comfortably supplied by my laptop's USB ports. If more power is needed than what's supplied by my USB ports, I often use an external power supply to power the Raspberry Pi and the connected circuitry. The Raspberry Pi's GPIO pins can only supply up to 50 milliamps, so it's advisable that any device that requires more than 50 milliamps from the GPIOs be supplied with an external power supply. The HDMI port uses 50 milliamps. The keyboards and mice can take as little as 100 milliamps or over 1000 milliamps. But since I use my Pi over a VNC server, I don't need to worry about these power demands. Check the power rating of the devices you plan to connect to the Pi and purchase a power supply accordingly. Now that the power supply needs are sorted, there are a number of ways documented on the Raspberry Pi website with regards to accessing the Raspberry Pi remotely. Most common is accessing the Pi using a secure shell or SSH connection, which is basically a network protocol for securely accessing devices on an unsecured network. But this method of accessing the Pi over SSH will only give you access to the command line, not the full desktop environment. So for my daily setup, I will only describe how you can access your Raspberry Pi remotely using a method that allows you access to your Raspberry Pi desktop. This can be done easily using a virtual network computing server or VNC server. VNC is a graphical desktop sharing system that allows you to remotely control the desktop interface of one computer running VNC server from another computer, mobile device running VNC Viewer. VNC Viewer transmits the keyboard and either or touch events to VNC server and receives updates to the screen in return. You will see the desktop of the Raspberry Pi inside a window on your computer or mobile device. You will be able to control it as though you were working on the Raspberry Pi itself. VNC Connect from Real VNC is included with Raspbian. It consists of both VNC Server, which allows you to control your Raspberry Pi remotely, and VNC Viewer, which allows you to control desktop computers remotely from your Raspberry Pi should you want to. By default, VNC connection is disabled. To enable VNC, you need to connect your Pi to a monitor and allow it to boot to the desktop display. On your Raspberry Pi, run the following commands to make sure you have the latest version of VNC Connect. Now enable VNC Server. You can do this graphically or at the command line. Enabling VNC Server graphically on your Raspberry Pi by selecting Menu, Preferences, Raspberry Pi Configuration, Interfaces. Ensure VNC is enabled. You can enable VNC Server at the command line using raspi-config. Run the following command. Now enable VNC Server by navigating to Interfacing Options, scroll down and select VNC. Yes. Now that the VNC server is running on the Raspberry Pi, you can install a VNC Viewer application on the device you'll use to take control, such as your smartphone or laptop. Download VNC Viewer. For best results, use the compatible app from Real VNC. For simplicity's sake, I have already established a direct connection using my mobile phone as a Wi-Fi access point to set a hotspot for devices to connect, including my Raspberry Pi. However, to connect to the Raspberry Pi using a VNC Viewer application on either smartphone or tablet or laptop, I will need my Raspberry Pi's IP address. IP stands for Internet Protocol Address, and similar to houses on a street with residential addresses, IP addresses are unique addresses used to identify each device connected to the same private network. So, to get the Raspberry Pi's address, connect the Raspberry Pi to the available Wi-Fi hotspot of your private network. Once Wi-Fi connectivity is established, on the Raspberry Pi's command line, run the following command. On the VNC Viewer, enter this IP address and give a naming of your choice on the name field. When you're done, click on the Connect button, and you should start seeing your Raspberry Pi on your VNC Viewer app. You can now start configuring your Pi in any ways you want. You are now running your Raspberry Pi remotely, either on a smartphone or a laptop, and at this point you can disconnect your HDMI monitor. Adjust screen resolutions and add icons on your desktop. Pre-installed on the Pi is the VLC media player, so what I like to do is to connect a 3.5mm audio jack headphones and either listen to some music or watch some movies. With my Raspberry Pi camera connected and enabled, I am able to take pictures and take some videos. You can also install Chrome, the Debian version, on your Pi to surf the internet, watch YouTube, etc. There are some pre-installed games you can play, such as Minecraft, but you can also create your own Python language-based games. There are some pre-installed programming environments such as Python, BlueJ, Node-RED, Mathematica, and many more. What's also great is you can also install other programming environments of your choice, such as the Arduino IDE. I encourage you to follow all the episodes in this series. The first 2 episodes are introductory, so as we proceed with the series, expect more hands-on approach in programming using the Raspberry Pi's pre-installed programming languages such as Python. Don't forget to subscribe and like the videos if you want to help this channel grow. Thanks for watching. See you in episode 3 of this series.